So the last couple of things here are, yeah, we're going to touch upon those topics later as well. But, well, if you remember what we were doing in the beginning, I sort of said that, okay, let's just focus on income, right? Is the one to be sensitive. But of course, you might have other ideas of which one is sensitive and how to protect them. So at the end of the day, make sure that we want to, first of all, think about what kind of relationships we want to keep, because those will be the ones that will go into your synthesizer or synthesis model. So I said, well, expenditure is gene sensitive. It is a continuous variable, so you can use some kind of regression. So that is probably still okay, based on what we know so far. For urban and rural and race. So urban rural, if you remember, is binary, right? So the linear regression that we learned so far wouldn't do. So today, we're going to cover, like, say, when you have binary outcome, what you can do. You probably have heard and probably have done logistic regression. That is, when you have binary outcome, you can model it. And then now we know if it's a Bayesian model, once you do MCMC estimation, you'll be able to get parameter draws, posterior draws for the parameters. From there, you can generate synthetic data by doing posterior predictor. Okay, so the general picture is both still the same. The actual model is going to be different, as we see, but the general procedure will be similar. Okay. Similarly for race, if it's deemed sensitive, it's an unordered categorical variable. I think has 6 different levels. And so today we're going to cover 2 different types of models that we can do. One is called multinomial logistic regression. So it's similar to logistic regression. Logistic regression, when you only have binary outcomes, so 0, 1, or 1, 2, or yes or no. But when you have multi-categorical, like multi-category categorical variable like race, when you have 6 or 7 or even larger, then you can think, yeah. Anyway, so it's called a multinomial logistic regression, and multinomial distribution is a way to think about how you can model that. So we're going to cover that. Another one to do is also to think about a multinomial random variable for race, or a variable like race. But there's a conjugate analysis exists for categorical variable like this. And we can have a conjugate prior, which is called the Dirichlet prior distribution for the categorical variable. And then that can be turned into a synthesizer as well. Okay, so we're going to talk about both of them. And if you read the paper that I asked you to do, you will see that they cover those methodologies as well. So in class, we're going to talk about, I wrote some simple code for you to take a look. And then later, I mean, either in class, whenever we do that, or most likely, I think, is in your project that you will have to go into the detail of how to use those models, and then how to follow what we did with the simple linear regression, how to do the generation of synthetic data for different types of models. Okay, so that's what we're going to do. And also, I posed the question back then that, well, what if you think 2 out of the 4 variables are sensitive? Okay, so far we only mentioned, well, if you have only 1 variable that is sensitive, we mentioned this few modeling strategies here. But what if you have 2 that you deem to be sensitive, and then if you find certain relationships that you want to preserve, and then how you're going to do that? So that will be another topic that we're going to talk about today. Again, if you read the paper, you would know that they're doing something that they call sequential synthesis, that they're doing one at a time. Okay, but one at a time, there's some trick or like some things that we have to pay attention to. So I'm going to talk about, well, why that kind of sequential synthesis will work and how you can do it in practice. Okay, so that's another topic. And I mentioned this really briefly. So there are 2 types of synthesis. One is partial, one is full. Well, with the partial synthesis, you can just think of it that not every observation or not every variable is being synthesized. Some of them are being considered as not sensitive, so they're just unchanged. So when we did the log expenditure and log income, it is a partial synthesis. Right? We think log expenditure is not sensitive, so we keep it, but we use it as a predictor to do synthesis for log income. So for that situation, this is considered as a partial synthesis. There are also full synthesis, meaning that all variables of every observations are being synthesized. Okay? So that is the case that people think, well, I think everything is sensitive. I better protect everything. So they can do a full synthesis. And so we have these two distinctions. Before we go to the synthetic LBD paper and all of those discussions, I just want you to think about like the two questions I pose here. When you have partial synthesis or full synthesis, let's just say for partial synthesis, maybe let's focus the second question just to get us going. What do you think the difference between, like now we know the partial synthesis and full synthesis, the distinction. What kind of implications can you think of that like partial synthesis will have for disclosure risk evaluation, and what if for full synthesis, what kind of implications that have for you? Just to refresh your memory, when we were talking about when we were talking about disclosure risk evaluation at the beginning, what we were talking about was two types: identification, right? And then attribute disclosure. Attribute disclosure. Okay. So my question for you, just for a quick discussion between your neighbors, is when you do a partial synthesis, do you think both disclosure risks exist? If you're doing a full synthesis, do you think both disclosure risks exist? Okay. Identification disclosure, just to refresh your memory, is trying to find out the identity of a record. Okay. Attribute disclosure is the disclosure of someone's sensitive value. So you're trying to like infer what that is. So my question for you is, partial synthesis and full synthesis. Well, partial synthesis, if you think about it, you're synthesizing all variables. So the risk in general should be lower. But to what extent? And I guess especially if you have two types of disclosure risks or disclosures. What do you think? Yeah, what kind of implications they have for partial synthesis and full synthesis? Okay, so take just a couple of minutes and then we're going to move on. All right. What do you all think?
Yeah.
For partial synthesis, do you think you can do you think we can still have identification disclosure and attribute disclosure? Both of them? Possible?
Possible, but harder than a full synthesis. Like harder to, or sorry, then it would be the opposite. Sorry, it would be more identification and attribute disclosure risk with partial synthesis. Yeah.
Okay.
Even though you can get some.
Yeah. Okay. All right. So let's see. So what's been like people's conclusion by now, but we might disagree later when we get to how to evaluate those risks, is when you do full synthesis, typically people think that there's no more identification disclosure because you change every variable. Remember how we were thinking about identification disclosure like at the beginning of the semester, even though we're not doing synthesis at that time, we're just saying that how can we evaluate how risky each record is if the record or if the data set is just released as it is, right? And back then we were trying to say that, well, if I know for sure like a particular combination of a record, then what I do is I would go in to the data set and then find how many are sharing the same characteristics. And then given how big that pool is, I can have maybe a high identification risk or a low identification disclosure risk, right? So with partial synthesis, you can still do that because for those unsynthesized variables, if I know for sure my neighbor still has this combination and those three variables like sex, gender, and age, and marital status, I think. Yeah, so gender, race, and marital status. If those three are now synthesized and I still know for sure that my neighbor is having that combination and then that my neighbor is in the data set, then I can still do some kind of identification disclosure, right? By doing what we were talking about before. However, when you have full synthesis, everything is synthesized. There's no, well, you can still try to say like, because you might still have synthesized records that are gonna have exactly the same combination, but because those are already changed, you never know if that will be one of those will be your neighbor. right? So typically people think full synthesis has no identification disclosure, and that's why a lot of times people would go for full synthesis if they can. And so later, once we get to that part of this intensive thinking about how to evaluate risks, we can revisit this and see if we still agree with most of people in the field. And attribute disclosure, I think it will exist. It will exist for either partial or full, okay? Because you're just guessing the value of a particular record. Of course, we'll have to make certain assumptions. But at least for full synthesis, it's still possible that you are trying to get to know a particular record. And for partial synthesis, we have seen that already. Okay, so I just want to bring this out early so you know that there are different types of synthesis. And then, of course, depending on, say, for your project, you can see whether you want to do a full or partial. By the end of the day, it's important for us to think about, yeah, especially once you have more than one variables you want to synthesize, what you can do. Okay. So that will be a focus of what we're going to talk about today, for the rest of today. So let me bring it up. Oh, yeah, go ahead.
I was wondering, did anyone do like something that wasn't a multiple linear regression for the synthesis part?
Yeah. So anybody did a non-multiple multiple linear regression for the exercise? Everybody did a multiple. And use all of the predictors for the exercise. I think as well.
Yeah.
Yeah. Okay. Yeah. I mean, again, I didn't check like how everybody. I was hoping people would just like volunteer, and then uploading it will be easier for me to bring up so we can see it on the screen and share that. So we're gonna do that for the rest of the semester as well.